Welcome back friends. Welcome back to another video session from this channel. So in this video session, we are going to study regarding the termination phase of the translation in case of prokaryotes. Is it okay? So the synthesis of the polypeptide chain, which has took place so accurately during the elongation phase, such specific polypeptide chain synthesis, it gets inhibited during the termination phase of the translation. Now here my question is, how the termination phase of the translation in case of prokaryotes it is successfully organized. Likewise, initiation phase and the elongation phase, the termination phase of the translation, it takes the advantage of a specialized factor, and these factors they are nothing but what? Release factors. So by taking the advantage of release factors, the termination phase of the translation in case of prokaryotes, it is successfully organized. Is it clear? So let me present it here. Release factors, right? So by taking the advantage of release factors, the termination phase of the translation in case of prokaryotes, it is successfully organized. So under release factors, there are two different subfactors. So what are those? One is class 1 release factor and the other one is class 2 release factor. Is it okay? So let me write it here. Class 1 release factor and the other one is class 2 release factor. So here, now my question is, what is the role of release factors here? The small subunit of the ribosome, it is unable to recognize the stop codons or the termination codons. Is it okay? The small subunit of the ribosome, it is capable to encode only the sense codons which are present in case of the mRNA, but it is unable to recognize, it is unable to encode the stop codons or the termination codons which are present at the extreme 3' end of the prokaryotic mRNA. In order to recognize, in order to encode the stop codons or the termination codons which are present at the extreme 3' end of the prokaryotic mRNA, the termination phase of the translation, it takes the advantage of certain factors, and these factors they are nothing but what? Release factors. So here under class 1 release factors, there is an availability of two different subfactors. What are those? Release factor 1 and release factor 2. Is it okay? Class 1 release factor. So what are the two different subfactors here? One is release factor 1 and the other one is release factor 2. Is it okay? So release factor 1, it is capable to encode certain stop codons or termination codons like UAG and UAA. In the same way, release factor 2, it is capable to encode certain stop codons like UGA and UAA. Is it clear? So let me present it here. UAG and UAA. And whereas release factor 2, it is capable to encode certain stop codons like UGA and UAA. So once when the specific class 1 release factor, when it gets successfully recruited to the A site of the ribosome, in the presence of class 1 release factors, the successful synthesis of the polypeptide chain, it gets inhibited. In order to inhibit the polypeptide chain, the specific class 1 release factor at first it interacts with the stop codons or the termination codons. So by interaction, the specific release factor it is capable to inhibit the polypeptide chain synthesis. So once when the specific class 1 release factor, when they recognize the stop codons or the termination codons, under such condition, the progression the successful progression of the small subunit of the ribosome in 5' to 3' direction, it gets inhibited, and even the synthesis of the polypeptide chain, which has took place so accurately during the elongation phase, it gets inhibited. Is it clear? Release factor 1 or release factor 2. So it is a part of class 1 release factor, right? So once when the specific class 1 release factor, when they were got successfully recruited to the A site of the ribosome, under such condition, the successful progression of the small subunit of the ribosome, it gets inhibited. And even the synthesis of the polypeptide chain, it gets inhibited. Now here my question is, how the class 1 release factors, they are capable to encode the stop codons or the termination codons. In order to encode the stop codons or the termination codons, chemically, the specific class 1 release factors, they are composed of a specialized tripeptide sequence, and the specific tripeptide sequence, it is nothing but what? GGQ motif. Is it clear? So the specific class 1 release factors, chemically they are composed of a specialized motif known as GGQ motif. So the specific GGQ motif, which is a part of class 1 release factors, they are capable to encode or they are capable to recognize the stop codons or the termination codons. So once when the specific class 1 release factor, when they encode or when they recognize the stop codons or the termination codons, under such condition, the small subunit of the ribosome, it is unable to proceed successfully in 5' to 3' direction. And even the synthesis of the polypeptide chain, which has took place so accurately during the elongation phase, it gets inhibited. So once when the specific class 1 release factors, when they are capable to encode the stop codons or the termination codons, and once when the polypeptide chain synthesis, when it gets inhibited, under such condition, one more other release factor, it comes into the picture. And that specific release factor, it is nothing but what? Class 2 release factor. Under class 2 release factor, there is an availability of a specialized subfactor, and it is nothing but what? Release factor 3. Is it okay? Now, class 2 release factor, right? Release factor 3. Now here my question is, what is the role of release factor 3 here? The specific release factor 3, it is responsible for the successful discarding of class 1 release factors which were recruited to the A site of the ribosome. In the presence of class 2 release factors, is it okay? The specific class 1 release factor which was recruited to the A site of the ribosome, it gets successfully dissociated. But the specific class 2 release factor, it takes the advantage of one molecule of GTP for getting recruited to the A site of the ribosome. By taking the advantage of one molecule of GTP, the specific release factor 3, which is a part of class 2 release factor, it gets successfully recruited to the A site of the ribosome. So under such condition, the class 1 release factor, initially which was recruited to the A site of the ribosome, it gets successfully dissociated. Is it okay? So let me present it here. So it is nothing but release factor 3 by taking the advantage of one molecule of GTP. So once when the class 2 release factor, when it was got successfully recruited to the A site of the ribosome, so under such condition, class 1 release factor and even the class 2 release factor, it was got successfully dissociated from the A site of the ribosome. Is it okay? So let me write it here. Successful dissociation of the release factor from the A site of the ribosome, it takes place in the presence of class 2 release factors. So once when the specific release factor, when it was got successfully dissociated from the A side of the ribosome, so under such condition, a specialized factor which is nothing but ribosomal recycling factor, it comes into the picture. Is it okay? After the successful dissociation of the class 1 release factor, one more other factor which is nothing but ribosomal recycling factor, it comes into the picture and it gets successfully recruited to the A site of the ribosome. Now here my question is, what is the role of ribosomal recycling factor? So as the name itself suggests, ribosomal recycling factor, that means the two subunits of the ribosome which were associated during the initiation phase of the translation, they get successfully dissociated during the termination phase of the translation. And again, the two subunits of the ribosome, they get successfully associated in the next round of the translation mechanism. So it is a cyclic process, right? Association and the dissociation of the ribosomal subunit, it is a cyclic process. In order to organize the specific cyclic process, the termination phase of the translation mechanism, it takes the advantage of a specialized factor, and that specialized factor, it is nothing but what? Ribosomal recycling factor. And that specific ribosomal recycling factor, it gets successfully recruited to the A site of the ribosome. Is it okay? Now, so let me write it here. Ribosomal recycling factor, or it is simply abbreviated as RRF. So once when the ribosomal recycling factor, is it okay? Once when the ribosomal recycling factor, when it has got successfully recruited to the A site of the ribosome, under such condition, the two subunits of the ribosome which were in an associated form, they are capable to undergo dissociation. Then after, one more other factor, it comes into the picture and it is nothing but what? EFG. Is it okay? So as we have already studied regarding the elongation phase of the translation. So during the elongation phase of the translation, a specific factor which is nothing but EFG, it comes into the picture. So the specific EFG, it is the specialized elongation factor which is responsible for organizing the translocation of mRNA. So again, the specific EFG, it comes into the picture during the termination phase of the translation. So here, what is the role of EFG during the termination phase of the translation? So the deacylated tRNAs which were in P site and the E site of the ribosome. Is it okay? Once when the specific tRNA, when it is in association with the amino acid, under such condition, the specific tRNA, it is under charged conformation. But once when the specific tRNA with its encoding amino acid, when it participates in the peptide bond formation, under such condition, the specific tRNA, it is under deacylated form. So in order to discard the deacylated tRNAs which were in P site and the E site of the ribosome, and even in order to discard the mRNA which is in association with the small subunit of the ribosome, the termination phase of the translation, it takes the advantage of a specialized factor and it is nothing but what? EFG. Is it okay? So let me write it here. EFG. So in the presence of EFG, the two tRNAs, the two deacylated tRNAs which were in P site and the E site of the ribosome, they get successfully discarded here. So let me erase the things here. So once when the deacylated tRNAs, when they were got successfully discarded from their respective sites, so under such condition, one more other factor comes into the picture, and it is nothing but what? Initiation factor 3. Is it okay? In the presence of EFG, the two deacylated tRNAs, they were got successfully dissociated, and even the specific mRNA which is in association with the small subunit of the ribosome, it gets successfully discarded. And even the nascent polypeptide chain which has took place during the elongation phase, it gets successfully discarded from the ribosomal machinery. Now, then after, one more other factor comes into the picture, and that specific factor, it is nothing but what? Initiation factor 3. The specific initiation factor 3, it gets successfully recruited to the E side of the ribosome. So let me write it here. Initiation factor 3. So in the presence of initiation factor 3, the large subunit of the ribosome which is in association with the small subunit, it gets successfully dissociated, right? So as I have already mentioned you earlier, during the initiation phase of the translation, in the presence of initiation factor 3, the large subunit of the ribosome, it is unable to associate with the small subunit. So the reason why at the end of termination phase of the translation, the specific initiation factor 3, it gets successfully recruited to the E side of the ribosome. In the presence of initiation factor 3, the large subunit of the ribosome which is in association with the small subunit, it gets successfully dissociated. And again, now the small subunit of the ribosome which is in association with initiation factor 3, it is capable to participate in another round of translation mechanism. Is it okay? So let me write it here. In the presence of initiation factor 3, the large subunit of the ribosome which is in association with the small subunit, it gets successfully dissociated, right? So let us assume it as the small subunit with its three respective sides, A side, P side and E side. So here the initiation factor 3, it has got successfully recruited to the E side, right? And it is nothing but the large subunit of the ribosome, right? So in the presence of initiation factor 3 which has recruited to the E side, is it okay? The large subunit of the ribosome which is in association with the small subunit, it gets successfully dissociated. And again, the small subunit of the ribosome which is in association with initiation factor 3, now it is capable to participate in another round of translation mechanism. So this is regarding the termination phase of the translation in case of prokaryotes. So I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.